does the square root of 49? That means that there are exactly two numbers that are exactly alike, and I mean down to the sign they're exactly alike, that when I multiply, okay, when I multiply these two numbers, they're always going to give me 49. You're like, oh yeah, Miss Peters, that's easy. That's 7 and 7. Okay, but there's another set too. There's the set of negative 7 times negative 7. That also equals 49, equals positive 49. So the concept of square root means I have two items that look exactly alike, that when multiplied together give me another number. Now, that means I want to know what can I do. Now, if I wanted to know what x was by itself, I could take the root y, square root of y. That's what it means. When I say the square root of y, I'm looking for what number am I multiplying, and I'm stressing that word multiplying, by itself to get what's underneath the radical. Do not mistake this for addition. That's what almost, oh yeah, you multiply by 2. No, we're multiplying two items that are exactly alike. We're not multiplying by 2. Now, the next question on our list would be, but Mrs. Peters, everything is always positive on the underneath the radical. That was a positive 49. Even when I multiplied two negative 7s together, I still got a positive 49. And somebody came along and said, yeah, but what if I wanted a square root of a negative 49? Well, using our square root properties, I can factor this. And remember, we are talking about multiplication, so we can factor. And I could factor a negative 1 out and 2 sevens. Okay, well, that would be the square root of negative 1 times the square root of 7 times 7, which then would be 7. Square root of 7, 7. Okay, well, that gives me 7, but I still have this square root of negative 1 in there. All right, and that's where your calculator, when you type in something that's got a negative underneath the radical, and it says syntax error, domain error, there's an issue here, and the issue is this square root of negative 1. Okay. It does not live in the real numbers. Remember the last lesson I said something about imaginary numbers? Well, somebody said, what if there is a number or something, just something out there, that when I multiply it by itself, I can get negative 1. And the guy goes, I'm going to make a symbol for it. In fact, I'm using my imagination, so I'm going to call this imaginary numbers. So this letter I is used to represent what I can multiply times itself to get the square root of negative 1. And we have this set of imaginary numbers. And if you remember correctly, when we were talking over here, this is what I was talking about when I talked about imaginary numbers. I'm talking about the square root of negative 1, or the letter I. And what's really nice is that I can make it follow all the rules of polynomials, because every set of numbers, we can group together all those real numbers and all those imaginary numbers, and we get that set of complex numbers, so that I can get something that has a real part, okay, and maybe it has an imaginary part. Well, that sort of acts like, sort of looks like it might be a polynomial. It looks like a binomial to me, actually. So guess what? Complex numbers are going to follow the rules that we need for polynomials. But first I want to talk about a little bit more about imaginary numbers. Let's talk about, okay, I already know that I is the square root of -1, and that if I take I and multiply it by itself, I get -1. Okay, that's also, we could call this I squared. Okay, what about if I had I times I times I? Well, let's see. That would be I cubed. Okay, I cubed, all right. That would be -1. Okay, that's these two here. And times another square root of -1. Because remember, that's what I is. So this is really -1, or the negative of the square root of 1. And this is usually how it's written. That's what I cubed is. Now, we go to I to the 4th power. And remember now, this is I to the 4th power. That means I have -1 times -1. Okay, so that's -1 times -1, which magically, when we type that in our calculator, we'll get the +1. So when I'm looking at imaginary numbers and I want to simplify my i's, like I to the, oh, I don't know, 18, I need to know how many perfect I to the 4th powers there are. So let's find out. I to the 4th times I to the 4th, that gives me I to the 8th, times I to the 4th, that's I to the 12th, times I to the 4th, that's I to the 16th, and I have 2 more i's happening. So this right here is I to the 16th times I squared. Well, those are perfect ones, remember. This was like saying 1 times 1 times 1 times 1 times I squared. So that would be equal to I squared, and I squared is equal to, what's I squared equal to, guys? I squared is equal to -1. So I to the 18th power is really -1. And that's what it means to be imaginary.